Hi, everybody. Welcome to another episode of the Future Tech podcast series. It's me, Charlie Sell, board director of Major Group, where I get a chance to interview, speak, just have general sideline chats with thought leaders, senior people within the world of STEM, who have all had many, many different ways of getting into STEM industries. And so it's with great pleasure I have Stephen Gornall with me today. Stephen is the head of engineering at ORDRE, and ORDRE is a leading fashion tech company that does quite a few different things actually, and some really, really interesting things. So, I think we'll discuss a little bit of that with part of Stephen's journey, as well as some really interesting concepts he's got about the building of teams and the type of people he looks for, which I have to say is quite a refreshing and unique approach. But I'll let that unveil throughout our conversation. So, Stephen, welcome to Future Tech.
Welcome. Thank you. Nice to be here.
So let's jump straight into it and tell us a bit about your personal story.
So my story is that I am from the north of England, and I went to start my career. I started engineering because I really struggled at school. If I'm honest, part of this sort of story I want to tell is that my STEM background is maybe a little bit different to a lot of people that maybe been on this podcast before. Because I really struggled with school. I have dyslexia, so that was a real challenge for me from the beginning. But I was very good at maths and science, not necessarily very good in the exams. I started off at school struggling to get the qualifications to go to college because I decided a bit early on, engineering is the sector I wanted to go in because I'm very hands-on. I'm very good at fixing things, repairing things. I used to spend my teenage years repairing Xboxes and other things like that. That's how I kind of got into engineering. Was what am I actually good at? Well, I'm good at repairing things and fixing things. That's how I got into. I cycle everywhere. So the other thing was repairing a bike constantly. I lived in the countryside, so I cycled to school. So I spent a lot of time at the side of the road repairing things and repairing electronics. That's kind of where my journey into STEM started. My journey into engineering was repairing and fixing things. Really, that's how I kind of got into it at a very young age. So I said, okay, and how do I be an engineer? How do I go and be a scientist of some description? That's the area I wanted to go into. So I went to school. I really struggled to actually get into college because I just said, I need to have A-level maths and physics to do a degree in engineering. So I wanted to be an electrical engineer. And that was a bit of a journey because I actually didn't get the grades that I wanted to get in. I originally, when I was 16 going into college, I actually failed one of my science exams, even though I was supposed to get a B. I got like a D. And so I very nearly didn't get into the course to be an engineer. And the reason for that was that because of my dyslexia, they didn't mark a whole 2-page essay in one of my exams. And so very fortunately, I actually got that exam paper. My science teacher very, very kindly said, no, it's so weird that you got 2 grades lower than you should have done. So remark the test paper. And I sent it back for remarking. And 2 months into the term at college, at 16 years old, they came back. My grade went from a D to a B, and so 2 months into I think it was literally like beginning of November even. So the term had already started, and I said, no, I sort of had to fight my way back into the physics class because they wouldn't let me in because I didn't get the grades. I said, no, I actually did. I just didn't mark my whole page. So that's kind of it was a real struggle. A few other stories like that, but that's the kind of struggle I had. That being someone with dyslexia, I knew I could do the job. My dad was an engineer. I have lots of family members and friends that were engineers, but I really struggled getting the academic qualifications to get where I am today, even though I knew I could do the job. So there's a few other stories like that, but that was just an example of how I so nearly didn't get where I needed to be, and really got to fight. So that was I did maths and physics and computing at college, and then I went on to John Moores. John Moores in Liverpool John Moores University to do a degree in electronic engineering. And that was very focused on a lot of people there were mostly from industry. So very few early students. Most of the people I worked with there at university were people that have come from BAE Systems, for example, and the defense companies around there. So I focused mainly on nuclear and defense. And that's what I did when I first left university. So I worked for a company called James Fisher Nuclear initially, working on stuff I can't tell you about really, because it was all very secret. But I worked in a number I was there very briefly to work on a number of projects. My brother still works there, actually works at Sellafield Nuclear Power Plant now. So I did that for a while. And then after that, I decided I wanted to be more in robotics. The nuclear industry was a little bit too paperwork heavy for me. I wanted to do something a little bit more hands-on. I say my specialty is kind of, I work with my hands. I can do the academic side, but why people hire me is because I make things work. And so I moved to London. I came to London, to King's College London, to do a master's degree in robotics. So I spent a year down here learning about robotics, not just the physical side, which I focused on, but I also spent a lot of time learning on, artificial intelligence, all the different algorithms that are being used as various buzzwords, but it's basically complicated algorithms and how we decide what robots should do based on the input parameters and past experience. So I spent a lot of time working on that. And then I started my job in London, which initially I actually worked for a company called Skyrocket Toys, which is an American-based. Most people listening from Britain won't have heard that, but if there's people listening from America, you may well have seen in like Walmart and Target and Costco. Skyrocket Toys makes lots of drones, laser tag game. We made small fluffy animals that make noises, that kind of thing. So it's a huge variety of toys. So most sort of European customers won't have heard of it, but if you're in America, you've probably heard of Skyrocket Toys if you've ever been to Toys R Us or Walmart. And so I spent quite a while there making toys, lots of different products. And again, it's a very practical experience. So electrical engineering, designing the hardware, writing the firmware, testing the products with the companion app. So I learned a lot of that company. It's quite a small company, but you kind of do a lot of different products very quickly, and particularly around costing, which is what everyone always wants to do, is make things a little cheaper. And so after working at Skyrocket Toys, I worked at a company called Canna Computing, which is one of the biggest campaigns on Kickstarter. I joined, I think, 4 or 5 years after they had their big break. And Canna Computing was a company that designs products to teach people about computing, about programming, about building computers. So that, again, was very practical. It was about the original product was based on a Raspberry Pi. So it's a Raspberry Pi, and you bought this product that was basically like a mini tablet or a mini computer for people. But the difference was that it wasn't just a product you got shipped in the post and could use. It's shipped in a box and you had to build it yourself. So it's an instruction manual. So you had to plug in all the cables, wire it all around, start the operating system. And that actually ran our own version of Raspberry Pi OS. Like, it was our own version of the operating system. And so I had lots of little games and challenges to learn about programming and about other aspects of the computer. That's where I worked there. I also did lots of products affiliations with Marvel and DC, Star Wars. So we did a Harry Potter coding wand, which you might have seen on the tube. It was a big product when it first came out. It was like a magic wand. Then we had gesture recognition, so you could cast Limgardium Leviosa and it would trigger the response in game. So we did things like that. And we also did a Star Wars Force game, so you could wave your hand over the product and it would trigger a response in the program. So it was mostly aimed towards children. A lot of the products were sold to children, but that was for really all age groups. So it was fun working on those products that have got to go from not just using the product, but you've got to build it when it arrives. You've got to test it and then ship it out to the customer. So that was an interesting job. And then now I'll jump ahead now to ORDRE. So ORDRE, as you said, is a sort of fashion technology company, which is what does that actually mean? So broadly speaking, we have a few different products, but we basically, and we've had products in the past that we no longer have anymore, but we try to be the company that brings technology to the fashion industry, because the fashion industry, like a lot of industries, but particularly fashion, is very bad for being a little bit behind the curve in some ways. They're a little bit old school. They're still using pen and paper. There's still physical showrooms. Everything's very old fashioned. People flying around the world to do things. We say, okay, well, how can we modernize a little bit more than running around with bits of papers and hard drives and things? How can we modernize that? So the main thing I've worked on while I've been at ORDRE is something called ORDRE 360, which is basically a portable photography studio. So you take this equipment, fits in the back of an Uber, and we can take it to your studio. So rather than the way most photography in the fashion industry is taken, is that they box the collection up, it gets shipped to a photography studio, they shoot it, and it gets shipped back. And that takes 5-10 days to get the images back. Whereas we will, because our solution is portable, we will build it anywhere where the collection is. So we'll go to the showroom, we'll go to your office. Doesn't matter if it's a little, as they often are, some little old building in Paris or London where the fashion collections, where the office is. We'll go and build it there. We'll shoot the whole collection in a day in 360. So the model stands on a platform, or the product stands on a platform, and the product will spin around. And we have our own software that talks to the camera, talks to our machine, and then talks to our cloud-based DAM. So the images are taken, they're stitched together, and then uploaded to our cloud platform, and then they can then be served to your website or Shopify or wherever you want them to be, and it will automatically pull out front, back, side, make a video. You can download GIFs or anything like that you would not need for social media. So it's kind of basically a way of modernizing the photography, whereas previously it would have been camera to an SD card, edited, back and forth, and it takes literally days. Whereas we can, we'll shoot 75 to 100 looks a day, and at the end of the day, when we're packing up to leave, everything's already uploaded to the cloud. And frequently, some of our clients will literally push it to their website the following morning after they've reviewed everything. So it's very, very quick turnaround time. So that's been something that we had a huge success. And then the other thing I should talk about is that we also have a new product that's just launching now. We just it was literally in the Business of Fashion, which if you don't know anything about business fashion, we were in the Business Fashion magazine literally, I think today or yesterday. There's an article out about Authentique, which is a product which basically allows you to identify which product is which. So you can have 10 bags identical off the factory. So say you've got 10 handbags, and our algorithm, you authenticate the product with our app, and you can do that with all 10 bags, and then you can shuffle them all up and give us back the 10 bags, and we can tell you which one's which, even though even a professional would really struggle to tell the bags apart. Our technology is able to authenticate to say that is not only a real bag, but that is specifically this bag, as though it had a printed serial number on it. We were able to tell, just like a fingerprint. It's the same sort of technology. We're looking at an image taken from an iPhone or an Android phone. Is this the correct bag? And that allows us to, particularly in the fashion industry, counterfeiting is a huge problem. So you don't have to sew in a QR tag or anything else electronic into the product. We don't have to interrupt the process. We just come in, we take a photograph of it at point of manufacture. So we have this authentication. And then when the customer buys that, they can also get the bag added to their wallet, to their sort of NFT or Bitcoin wallets. So we have our own wallet systems based on that technology. It's on the blockchain, and so that will allow you to prove that bag is real, particularly if you want to resell it. So it's kind of counteracting counterfeit, but also allowing you to verify that bag is an original bag, or maybe it's part of a limited collection. There's information about that that's digital that can be transferred to somebody else, or just show people on your wallet that you've got something that's proof it's real. So that's technology we're currently launching, where we've got a contract with a couple of big brands. Probably can't say their name yet, but we're launching it at the moment.
Yeah, wow. Well, what an interesting story. And I know we're going to move on to it. The route to being able to acknowledge and understand that even with dyslexia, that wasn't a hindrance if you work out how to use it, I guess. And the more we discuss these type of things, the more we can get rid of a few misillusions, isn't there? I bet there's probably a few misconceptions that, as you mentioned at the very beginning, that stem, you have to be a maths, master's graduate, or you have to be able to think incredibly quickly, numerically, on the spot to be able to really have a career edge. I know is not the case, and you actually actively look for people who can work with their hands and build it. So let's discuss that a little bit more, and tell me a bit more about how do you build your teams, and what is it that you look for when you are building your teams, and how you get around those misconceptions.
Yeah, absolutely. So, part of the products that we have, now, and particularly when I work for the physical products companies, when you're making a physical product, whether it be a children's toy or a computer or a laptop, or, my current case, sort of custom photography equipment, there's such a huge amount of skills required to build that machine. So you've got to prototype it. So someone's going to physically, 3D prints, CNC, mill, lathe, whatever it is, to make that prototype, design it in CAD. And once you design the product, you have to productionize it. So how do we take this thing that we've manufactured, how do we then go and make 100,000 or 1 million of these things? So there's also supply chain management. There's quality control, quality assurance. There's all these different aspects of the product that is often not discussed as widely as it should be. And that's really very much part of STEM. Yeah, sure, you need your straight A student software engineer that's going to make the software side work, but what's so often overlooked these days is that practical mechanical knowledge that is needed, the common sense knowledge that is needed to drive that industry forward in other areas, because everything is ultimately driven by the hardware. And the reason all the software works is because our laptops get faster and faster every year. Our phones get faster and faster every year. That the internet gets faster because everyone's building new servers. cars and everything is getting more smart because people are manufacturing these parts that's you know, often overlooked in this sector. So it's really, I find it quite a challenge to hire people that can still have these skills that are seen in some respects as traditional. So they're seen as, well, we don't really do that anymore. You know, nobody works with their hands anymore. Nobody you know, manufactures things from scratch. Nobody tests things manually. Everything's done, you know, or maybe it's done overseas or whatever. It's not needed in the industry. And it absolutely is, you know, whether you're, you know, in a laboratory testing something, or whether you're in a manufacturing facility designing something to be made, we need those skills, you know. And so what I end up resourcing to is that, you know, so our foreman, the guy who runs our factory, used to be a furniture maker, and before that he was a tree surgeon. We were just talking about this morning. Someone was saying, "Oh, you want to come back to tree surgeon?" And I'm an engineer now, because you know, that's where we have to go to find those skill sets as well. Where do we find somebody that can use you know, a lathe and a milling machine, but can also, you know, write a bit of code, or can also you know, build something and test something, and spot mistakes that we wouldn't have spotted until it's too late, you know. So finding somebody to have those skills, and that is very much part of STEM, part of engineering. So finding people that can have the knowledge of that, and particularly for mechanical engineers. I hire a lot of mechanical engineers. You know, everything's done in CAD now and simulations and stuff, but there's real one skill set that I'm constantly looking for that is really quite sparse at the moment, is how many mechanical engineers have machined something. So if you're designing something to be CNC'd, it really helps if you've designed that and then built it on an actual hand machine. You've laid that out, and because it sort of changes the way your brain works, and oh, I know how to make that now, so that it makes your designs easy to make. You know, I've lost count of the times I've sat down with an engineer and gone, it's great, it looks fantastic, the render's brilliant, but we can't make this, because we can, it'll cost an absolute fortune because you've not followed the procedures that are required to you know, to cost this part down. You're using too much metal, you could cut this bit out of here, there's too much volume here, it's going to flex because you've taken too much material out here, not enough over there. Or particularly with injection molding, you know, if you can, which everything's injection molded now, if it's not 3D printed, there's a bit of a challenge now for switching to 3D printing, but people still need to be able to manufacture stuff that's out of molds. And if you've got that practical knowledge, if you can, you know, get in and fix your bike and understand, okay, this is how this goes, this is how that goes, it's really powerful to be able to say, not only can I build this in CAD, but I know how we're going to make it as well. Because that's the challenge, is, you know, you can design something very pretty in the computer, but how do we actually get it to be something that's usable by the customer? And how do we test that? So another thing is, you know, when you've built something, our equipment now is shipped all around the world, and like I say, it's transported, so it gets packed down, put up again, packed down, put up again, you know, maybe 50, 100 times a year, depending on what market it's in. So how do we design something that's going to be packed down and rebuilt 100 times? And that takes, you know, someone with the knowledge of, oh, well, I can go and fix that. I can, or we need to fix this because this bit's it works 10 times, but on the 12th time it breaks. So we need to identify and repair that issue from the very start. So, you know, I'm always looking for people that can have that mindset of, you know, not just the technical software side, the computer side, and that design, but also the physical and practical skills. And it is, you know, frequently I've talked to people who go, well, you could be an engineer, you are actually a STEM person, you know, just because you're some people call it a maker. It's a sort of common word that's being used now. But to me, makers are STEM. You know, if you're manufacturing something. So a classic story we tell is that we hire frequently dressmakers because we work with fabrics. So if you want to make fabric sides for a product, or you want to make something, then you need to go and hire someone who knows how to make fabric side. And so that to me is also science engineering. Is something that somebody can manufacture products to do that. That's a big problem, and it's really, really very difficult to find an engineer that describes themselves as something that can use fabric. You know, someone who's used to upholstery, it's very complicated to find someone that can do it. We literally had to go around and find someone. Oh, you're making dresses, but could we pay you for 6 months to come here and help us make this other thing? So there's loads of examples like that where somebody go, okay, how can we manufacture that? And particularly during COVID, there's a big challenge because we kept going during COVID. So we did a lot of local in-house manufacturing. So we hired set builders and bricklayers and everybody else who was not working at the time to come to our factory and continue working. And that, you know, it's incredible how much work you can get done if you've got people with the right skills. And you know, too few of those people don't see STEM as a career option for them. And I absolutely think it is. And it's something that helps, you know, drive the business forward. And also it's an area that, you know, if there's anyone listening that building a team, I think it's really important you have at least 2 or 3 people on the team that have that practical knowledge that can go, what's the issue, and they're not relying on the IT team to fix computer issues, so you have somebody there that's got that practical knowledge.
Yeah, and it's, as I said at the beginning, this is so refreshing when, because the vast majority of the people I speak to, you're right, are incredibly inspiring people, but from the pure software backgrounds, which has progressed, beyond belief over the years. But with automation and AI and VR, it's more about becoming a master of code rather than, as you say, remembering that there needs to be physical hardware that this has to be incorporated in, that has to be built, that has to house, if not develop it all. So to hear that, you're giving real life examples to many of our young listeners who do want to use their hands and maybe put off by STEM, presuming it's purely academic or algorithms. There isn't. There's a huge market area where you can get into STEM and even engineering from a practical point of view. So taking that as our lead into the career advice, and there'll be people listening to the podcast who, may hopefully will be quite inspired now, thinking, okay, there's other routes, but how do I get into it and how do I stand out? What one or two tips could you give a young person if they want to try and get into this side of STEM and engineering, and how could they stand out?
So to me, a big thing that I'm always looking for, and I know a lot of other employees are looking for, is, so often you're looking at a CV and going, yeah, okay, you've done this skills, you've done that skills, but what really impresses me is doing some sort of project, doing something in your own time, something a little fun, because it's one thing talking about something, and this is a problem we have with that. Say to me, being practical is being academic, but it's unfortunately not the way we measure that sort of intelligence. And we don't have systems in place to know, well, how do you know if you can fix something? So my advice would be, a really good one is Arduino. Internet of Things, Arduino. You can buy a kit. It's very inexpensive. It doesn't take up a lot of space. But going and making a physical product and testing it and having something to show, whether it's a printed circuit board of a project you've worked on, if you're repairing an old Land Rover for fun, then bring some photos to the interview. Bring a little circuit to the interview to show, or particularly if you're at university, for example. It really upsets me that this is the case, but unfortunately, very rarely are you actually forced to make anything. So every electrical engineer, for example, makes a taximeter, like a meter that as the car's wheels spin, it counts up the counter. Okay, we'll make that. It's a really simple product to make. So you have that learned experience, because that really impresses the people that are going to hire somebody. Unfortunately, it's difficult to find people that value that skill set, but when you find them and you show up and say, yeah, I've done this and I've done a bit of that, but here's my project I've been working on it, and it literally could be a little something in your house. Maybe you've made your own custom keyboards. Maybe you've got a water sensor for your plants or something. You've done some sort of automation with a Raspberry Pi to do something. Maybe you've got a 3D printer if you're fortunate to have one of those. Like, what have you made with that? So that really, because it's so difficult when you're an interviewer to say, well, and because with practical skills, you can't really give someone a coding test. Occasionally you'll see people giving people like a soldering test, or can you fix this, like a little project, in like a 20-minute interview, just like a code test would do. Like, is it something we can do quickly to show that you can do those skills? With a physical test and someone using the hand, it's very challenging to get to know somebody. I've earlier in my career, my job at the toy company I talked about earlier, I actually wasn't hired initially. I was hired as a contractor for a month, and then they gave me a full-time job. And the reason was that I was like the 7th person they'd hired, and the 6 other people beforehand didn't have the practical skills and lost the job within about 6 months, because they were hiring people that said, oh yeah, I can do this, but they couldn't find somebody that actually when he showed up for a month in, well, you can't do that. So going to the interview, if that is your skill set, show it off. Just like a software engineer will show off how fast they can write the code, and all the different functions they'll use, and the advanced programming techniques to reduce memory and all this sort of stuff. Well, if you're trying to sell that physical skill set, take something physical to the interview. Even if it's some fine woodworking you've done, you made a little wooden box. That's the sort of thing we really like. Or you've made a really cool bottle rocket, or you've sent something into space. That's the sort of thing that really excites someone that's looking for practical skills. Of, oh well, I don't know how to do that, but you've shown me something that's a skill that and it's a way of us measuring that you can do something that's very difficult to get across in an interview any other way. So that's the first thing I would say is to make something practical. That's a big one, is to show something physical to the interview. And we're also engineers, we like that sort of thing, so it's a good thing to do.
Yeah.
So, and the other thing I would say is, this is more of a more general thing, is particularly if you're early on in your career, I would say pick the company, not necessarily the job. So I found that it's very, particularly if you're practical skills, but also if you're a software engineer, I think earlier on in your career, it's really helpful to go to a smaller company. There's maybe do something a little bit interesting. That's because you might not know what you want to do. So if the issue is that if you go to a big company, like I work with a lot of people that started their career at Google or Microsoft or Facebook or something, and that's really exciting, but they've done a very, very small part of a much bigger picture. And it's frequently they go, oh, well, I was doing here, but it took me 5 years to figure out I should have been over here. So if you go into a smaller company and say, right, well, what do I want to do? Because it's one of those jobs as an engineer, it's such a broad subject and there are so many different areas to specialize in. You really want to try out a few, because one of the big selling points, not just in engineering, but in most careers now, is flexibility. And that engineering is a big, very rarely will you get hired with a skill set that exactly matches what you're trying to do. We have this argument all the time that when you're hiring employees for an engineering team, very rarely can you write a job spec and hire someone that ticks all the boxes. It's very unusual to find somebody, because engineering by its nature, we're solving a problem that hasn't been solved before, so we wouldn't be bothering, right? So trying to get as broad as experience as you can, so early on. So like picking a company that's maybe a little smaller, that's just doing something you're interested in, and pushing yourself to go, oh, well, I want to try a bit of this. Everyone should do a little bit of programming and a little bit of practical and a little bit of, firmware, cloud software. Try a few things out. Maybe you want to be managing stuff. Maybe you don't want to be managing stuff. Just doing that early on. And so, I think it's really important to get that breadth, because frequently, I've had people that work for me that go, oh, actually, I want to be a UI designer, when I was a physical designer. So having people having that experience early on really helps. And not just it helps you find something enjoyable to do, but it also helps the more stuff you've done a little bit of, the more of those boxes you're likely to tick. You could say like, oh, I've done a few different programming languages, or I've done a little bit of cloud server, I've done a little bit with this. The more stuff you can do, because it's really easy to go to an interview, oh, well, you can do all this, but there's a few boxes missing. Well, the more you've done, the more boxes you're going to get. And then my sort of last point, and it's a similar point, but not just earlier in your career, but I always say that it's really useful to change careers frequently. So what I mean by that is change disciplines. So if you're working in automotive, go on to renewable, power energy. You're working in consumer electronics, maybe try something else, because again, it's all about flexibility and building in that, building in the ability to be able to do lots of different things and answer as many of those questions in the interview, because that's how you get the good jobs, is where you can do something that, well, nobody else has done this before, so we want someone that's done a lot of other stuff that's applicable to this job. And that goes right the way through from a small company or working for a big a big company that's doing something exciting. They want the people that have done the stuff that's broad enough to go, well, you're probably going to be good at doing something that no one's done before, because you've not just done one type of engineering, you've done a whole bunch of different, whether it's software engineering, different languages, or physical engineering. The more little bits you can do earlier on in your career, the easier it is, I think, to get a job that's going to be enjoyable in the industry.
Well, Stephen, what great advice, and especially, well, all three, but having examples, showing your learned experience, picking the company, not just the job, and having that diversity in jobs, having that diversity, trying different career paths. This is what the future, the new generations are about, and I think that's just fantastic tips and and your ideas. So, as always, these podcasts fly by. I could talk to you for hours, especially around the practical side of engineering, as you so rightly said. It's open to many people. But Stephen, thank you so much for being a guest on the podcast.
It's been a pleasure. Thank you.
And so, to all of our listeners, that's another episode of our Future Tech podcast. As many of you will know, it's shared by the STEM Ambassador Association on Spotify, on our Arrows Group podcast, and on LinkedIn. So for all the listeners, thank you for listening. And to Stephen, one more time, thank you for being a guest. And here is to the next one. Thank you.
Thanks.